Alright, so we're going to go over the quadratic formula today, which is this formula here. This formula here solves for x. Many people forget that it solves for x, okay? So what we're trying to do is, if we're in standard form, find values of x that make the equation true. Now, in order for us to use the quadratic formula, we need to be set equal to 0. Okay, right now we have a y, but we're replacing y with 0 because we're finding x-intercepts. That's the goal here. Okay, so this formula states negative b. So in this case, you take the b, and if it's a positive value, you plug it in with a positive and a negative in front of it. And we'll get into an example like that. Plus or minus, this sign means we're going to add and subtract the rooted answer. The reason being is because the square root of some number like 25, let's say, is technically positive 5 and negative 5. There are two answers to that. Negative 5 times negative 5 is 25, and so is positive 5 times positive 5. So that's why we will be adding and subtracting that answer. We'll end up getting 2. Subtracted by 4 times a, which is this value here, c, which is this value here, and everything is divided by 2 times a. Not just the square root. Many people make that error also. The entire equation. So in other words, you have to equate everything on top and then divide it by 2a. Okay? Also, in order to plug values in for a, b, and c, we need to be in standard form of a quadratic. Okay? So if you're in vertex form or factored form, you can't plug into the quadratic formula, nor do you really want to. Because if you're in factor form, you can find x-intercepts very easily. If you're in vertex form, you already know the vertex, so it can be simple to find the x-intercepts. Standard form is where it's hard to find that information. And sometimes we're unable to factor something, so that's when we want to use our quadratic formula. Now, the quadratic formula will work for any example, so we're going to put one up here. Example 1. 2x squared plus 9x plus 6. Okay. Is equal to 0. So we're trying to find our x-intercepts. The very first step is what is usually easiest, because we've been doing this for a very long time, is you might want to try to factor this. Okay? We look at it as factors of 2 are 2x and 1x, and 1 and 6, and 3 and 2 for 6. And we jump through this, 6, 7, 8, 12, 1. We're really not going to get any factors that work. Okay? It doesn't mean that there's no x-intercepts. What it means is, for factoring, is we're just not able to go through this process to get it. So what we're going to try next is the quadratic formula. So we need to know what our a is, which is 2. Our b is the value of positive 9, and our c is 6. We're going to plug that into the quadratic formula, which says x is equal to, remember, it's x is equal to negative b plus or minus the square root of, I'm going to color code it so it's easy for you guys, b squared subtract 4 times a times c, and everything is divided by 2 times our a value. Okay? So if you notice, b comes into play twice, a comes into play twice, and c is only once. Okay? So let's take our b value, which is 9, and we're going to plug it in. So we get negative, and I'm going to plug it in with its integer in front, just so you guys get used to this. Positive 9 for b. Plus or minus square root of 9 squared, because that's our b. 9 squared minus 4 times our a value is 2. Our c value is 6. And everything is divided by 2 times our a value again, which is 2. Okay? So we plugged all of these values in. We've got to go through BEDMAS to solve this. Because we have a negative in front of the positive 9, what does this term become? Negative, that's right. This becomes negative 9 plus or minus, we'll get to it again, 9 squared is 81. Now I have negative 4. Think of this as a negative 4 when you're multiplying it, okay? So negative 4 times 2 is what? Negative 8 times 6? No. Negative 48. And 2 times 2 is 4. Okay? So, we continue from there. We have to subtract 81 from 48, which is going to be 33. So we get negative 9 plus or minus the root of 33, all divided by 4. Okay? You can choose to find the root now or after, but what we're going to go from this point is we're going to split the equation. Okay? And the reason I'm going to split the equation is because remember we talked about there being a positive and negative answer? Well, there's going to be a positive and negative answer to our square root. So I'll actually find that square root, root 33. Anyone got a calculator with them? Should I bring one up? Right in front of you. You're giving it to me? Great. Okay. Root 33 is
5.744.
perfect. 5.744, we'll leave it at. Okay, so we'll go one more step farther. Negative 9 plus or minus 5.744 divided by 4. Now again, we talked about that plus and minus. What we're going to do from here is split the equation. Is there any other thing we had split the equation with previously? Anyone remember? Some cross factoring. When we're factoring, we have to split the equation, right? And the reason we're splitting the equation is because we're going to be finding 2 answers. Okay? So we're going to split this equation because there's most likely 2 x-intercepts. And we're going to end up with x is equal to negative 9 plus 5.744 divided by 4. And x is equal to negative 9 minus 5.744 divided by 4. Okay? We're then going to equate this. So, negative 9 plus 5.744 divided by 4. Who wants to help me out here, the calculator? The answer becomes negative 0.814. Great. And then our other example, negative 3.69. I think. Yeah. Okay, so what we've discovered is our 2 x-intercepts to be negative 0.814 and negative 3.69, which makes sense why we weren't able to factor this. Factoring this, we wouldn't have got an answer like this, okay? So just because we can't factor something doesn't mean it doesn't have x-intercepts, okay? Now, there are parabolas that don't have x-intercepts, but in this case, we found one. So let's say we were to actually graph this, something like, let's zoom in again. If we were to graph this quickly, what this means is we have 2 x-intercepts, or 2 values for x. There are 2 answers. One at negative 0.814. Yeah. Okay. And the other one at negative 3.69. Okay. If we quickly look above, this is a parabola. Our a value is positive, so which way does it open? Upwards, that's right. It's going to open upwards. So we know we have something that goes like this. Oops, I kind of missed it there. But we have something that goes through those 2 points. I gave you another formula for AOS in standard form, which was b, or negative b, divided by 2a. Okay? So if we take those values, our b value was 9. So negative 9 divided by, and our a value was 2. 2 times 2. Okay. Oops. 2 times 2 is 4. We still have to multiply. Okay. So we end up with negative 9 over 4 as a decimal. What is it? 2 1/4? 2.25? Yeah. Okay. So what this means, axis of symmetry, or the x value of the vertex, is at negative 2.25. Okay. Oops. Don't want to end that yet. Okay. So our axis of symmetry falls through this point here. I'll move that over so it looks accurate. And finally, how would I find the y value of my vertex?
Time divided by 2.
No one knows how to find the y value of vertex? No wonder that quiz didn't go well. You take this value. Oh. You need to plug it back in to the original equation. Okay? So, the original equation, y is equal to 2x squared plus 9x plus 6. We need to replace our x values with this here. We replace the 2x values. We get y is equal to 2 times negative 2.25. I'll need someone with a calculator to help me out here. 9 times negative 2.25 plus 6. Did they give me an answer here in the book? Not really. Anyone know what that's going to be? That's what the answer is? Negative 4.5? Oh, you did this one step. Okay. Who can do everything in one shot for me? What'd you get? 77? So we end up with an answer, our y value being negative 18.75, which is logical. Okay, you might want to double check it, but it's logical because that's below our x-axis, and we knew this was a parabola that opened upwards. So we still have to apply some of the old rules, but we may run into quadratics where we cannot factor the answer, and that's when we got to use the quadratic formula to solve this. So I'm still able to sketch just using the quadratic formula for more difficult type questions.